So welcome everyone to tonight's class, which is on efficient supplemental irrigation. All right, so tonight's conversation is about irrigation, and we've got this honeycomb that represents the idea that everything is connected. So we are not simply looking at an irrigation system, but really wanting to understand how irrigation fits into the bigger picture. So as we go through the evening, the first honeycomb is remembering the basics. Number 2 is proper design. Number 3 is proper installation. Number 4 is actually converting spray to drip. Number 5 is taking a closer look at an irrigation timer, how you work with your irrigation controllers. And then number 6 is about maintenance. So let's go ahead and start with the basics. So irrigation does not exist in a vacuum. It exists in a landscape. And in order for that irrigation to be as efficient and as effective as possible, we actually want our landscape to be as healthy as possible. And so we use the term watershed as a model or a lens for looking at a landscape that is thriving and is resilient. And there's 4 key components to it. So the first one, and probably the most fundamental, is the soil. Making sure that you have what we call a living soil sponge, which means that lots of nutrients available for the plants. When it gets water, it can hold onto it, releases it to the plants as they need it. Number 2, still with the topic of water, rainwater, holding on to rainwater wherever and however possible. Number 3 is selecting climate appropriate plants. And yes, there's absolutely a focus on natives, but it does not have to be exclusively so. And then the last one, tonight's topic, is making sure that we look at irrigation as a supplemental source of water, not as the default, and that obviously it is as effective as possible. So even with all of that, with that healthy soil, and we're holding on to rain when we get it, and we've got our climate appropriate plants, there will be times when our gardens are going to need additional water. So such examples are even California natives in a garden setting may sometimes need extra water, especially in the summertime. Obviously, depending on when they're installed, if you put your plants in May and we don't get rain until November, something has got to carry them through until then, and until they get enough rain to be able to start getting established. And then as we are seeing, the climate is getting more and more erratic. So a few years ago, we had these deluges. It is just a matter of time before we go back into a drought. And so making sure that water is available to the plants when they need them. And the conversation is about efficient irrigation. And really, except for lawn and large areas of ground cover, drip is going to be the most efficient way of watering your plants. And so we wanted to do this side-by-side comparison so that you could understand why drip is the better way to go. So the first one is the rate at which the water is developed. Oh my goodness, excuse me. The rate at which water is delivered. So with drip, water is delivered in 1 gallon per hour. So it's literally dripping. With spray, it's delivering 1 gallon per minute. Number 2, it delivers that water directly to the plant compared to spray that goes out all over the place. The advantage of those first 2 is the water is going to the plants right where they need it, and it is being delivered slowly enough that the soil can actually absorb it. So we're not getting that runoff, right? With drip, there's also next to no evaporation compared to spray. Another big advantage is the weeds. Plants grow where the water is. So if we don't have water everywhere, that is going to start to limit other plants that are coming up that are perhaps not as welcome as the ones you put in the ground. And then we talked about how the soil has the ability to absorb that water more easily when it's delivered more slowly. And that means we are not wasting water with the runoff. So here is that comparison. This is 1 emitter, 1 spray head. I run my irrigation for an hour. And with drip, I fill up a gallon jug, With spray, I have filled up 60-gallon jugs. So there is a huge difference between the amount of water that is going out into the garden and the amount of water that's actually being used by the plants themselves. And so irrigation is not just applying water. It is really about maintaining that proper balance of oxygen and water in the soil. We always think about the water. We don't realize that there's another critical element in there, and that is the oxygen. So if there's not enough water, we know what happens, right? Our plants get droopy and eventually they will die. Lots of oxygen, not enough water. But what we have to be careful of is that the opposite can also happen. And that is that there is a lot of water and not enough oxygen. And when that happens, you actually start to create an environment for what we call anaerobic life. And anaerobic life that is where we start to get our diseases and our pathogens. So we are looking for that sweet spot where we've got just enough water and we've got just enough oxygen. And tonight is how we accomplish that. So once again, irrigation is not just about the water. One of the key things you will need to understand is what type of soil do you have? And in that guidebook that Sana referred to, we will actually give you information on how you can test that for yourself. There's a couple of different ways that you can do it, but it's important that you actually do it. Take it in your hand or put it in a jar and go, oh, I've got sandy soil, I've got clay soil, I've got loam soil. And the reason it matters is because depending on the type of soil you have, this is how your water moves through it. So with sandy soil, we've got big particles, big gaps, so the water moves through it pretty quickly. Clay soil, small particles, small gaps. So the water hits the soil and it's much slower to make its way through the profile. And as a result, that water is actually spreading out before it goes down. And understanding these patterns will actually really help you when it comes to designing your drip irrigation systems. Now, the next question is going to be, well, how much water does my particular plant need? The way that is measured is through something called evapotranspiration. That is a combination of evaporation and transpiration. So that is the amount of water that is lost from the soil itself. And then there's the amount of water that is pulled from the soil into the plant and then out into the atmosphere as vapor. And those two things together, that evapotranspiration, is how much water an individual plant will require. So here we've got a range, a spectrum of plants. At the far left, you've got sort of a poster child for a high water using plant. You've got turf. That water, it's evapotranspiring very, very quickly when you have turf. Anywhere between 40 to 50 inches per year is being required in order to keep that turf green. We start making our way to moderate water users, low and very low. And you can see that the amount of water that is evapotranspiring starts to lessen as we make our way. And so when it comes to irrigation, as we move into the low and very low, we are potentially having to apply much, much less water, less frequently. And you get to that very low, which are many of our native plants, it could be months in between irrigation cycles. All right, so if at any point you've got questions about just this fundamental understanding what irrigation is, or something pops into your head, don't wait until the end to ask your questions. All right, so let's go to number 2, which is all about properly designing an irrigation system. And we will be focusing specifically on drip, but we thought it was important to actually have an understanding of the big picture. What is involved in an irrigation system? And it's tough because a lot of it is underground or, it's in the garage. In the case of your controller, it comes on at 4 in the morning when everybody's asleep. And so it's kind of this mysterious thing. And yet so much is affected by this irrigation system. So water comes in from the water provider. It goes through a meter. This is how you get your water bill, how it detects how much water is being used, and then it makes its way onto the property. And from there, there's a couple of options. Uh, in some cases, the water will go into the house to provide water for the interior. And then from there, it goes out into the landscape and then it waters the garden. In other cases, the water comes onto the property and then it splits and a pipe goes to the house for the interior and a separate pipe goes out to the landscape to water the garden. And there is no right or wrong, but it's just a good thing for you to know. From there, there are some different elements that you want to be aware of, whether or not you have them or don't have them. It's good to know what they do. The first one is a backflow preventer. So what happens with an irrigation system is a valve comes on, your lawn, your spray head comes on, or your drip comes on, water goes rushing through the pipes. And then when your irrigation is turned off, that valve is turned off, the water will actually get sucked back into the pipes. And if there isn't some form of backflow prevention, and I'll show you a couple of different methods, there is the potential that that water could actually get pulled back into the potable system, and that water is no longer clean, right? It's been pulling back potentially soil or bits of plants or what have you. So we don't want water that's been delivered out to the landscape to get pulled back into our potable water system. Next up is pressure regulation. Water is delivered onto the property at a particular pressure. That's measured in pounds per square inch. We're looking at about 50 or 60 is the ideal for the interiors. And then that pressure is often reduced, should be reduced as we move out into the landscape. Oftentimes what will happen though is the pressure is much higher than what is appropriate for the property to actually run efficiently on. So that pressure regulator will actually lower the pressure so that it is what it needs to be. From there, we go out to the valves. There are valves for the different zones. So potentially there is a valve for the lawn. There's a valve for the edibles. There's a valve for the natives, etc. But basically, ideally, you have one valve for each zone. And there, after that, you go to spray, or you go to drip, or you go to bubblers, or what have you. And then the last piece there is the controller. It can be inside, it can be outside, and it is basically the brains of the operation. So it tells the valves when to come on and for how long to stay on. So here you go. We've got the pressure regulation here on the left. You've got what are called master pressure regulators. So they will regulate the pressure for everything that is downstream. You can also have regulators on the valves themselves. So when we're looking at a drip valve, 15 to 25 is typical. With spray, the pressures actually can be a little bit higher. Now, I had talked about backflow prevention. When it comes to most residential homes, you're actually looking at anti-siphon valves as the way of providing that protection. So basically what it does is it works with gravity. So when that water gets sucked back into a pipe and it starts to go up, those valves are supposed to be a minimum height above grade, or actually above the highest head, so that that water can't then flow back into your potable system. A couple things to point out is that the valves should be low flow. Again, remember that a drip system is delivering water in gallons per hour compared to spray, so a much smaller volume of water is traveling through them. So we want to make sure that the valves can accommodate that lower flow. And then, as is typical for a drip, you can see the filter, and then right below the filter, you can see where the pressure regulator is. Now, in some cases, you've got valves that are actually underground. So these are not anti-siphon valves. These will not provide that backflow prevention. So in that case, you would require a mechanical system to do the same thing. But you can see, oh, it's a drip system. There's the filter and there's that pressure regulator. Now, taking a look at the drip specifically, the drip line, this is inline drip, which is what is rebated. And it has emitters that are already built in, and those emitters are at regular intervals. So they're at 12 inches or 18 inches or 24 inches, and they are the same throughout the entire tube. And they are ideal for a grid pattern. So if you've got large swaths of ground cover, for example, and you want like this really even coverage, inline is terrific for that. And we'll actually give you some tips on installing grid patterns in a little bit. So you can see here that things that you need to be thinking about as you are designing it, or you're working with a professional to have it designed, is you've got the distance between the actual emitters. We said 12, 18, 24 inches. But the other thing that has to be considered is the distance between the actual lines of tubing. So that is not a random number either. And the spacing of both of those elements between the emitters and between the lines themselves has to do with the soil, right? So if you remember the way that the water moved through the soil, with sandy soil, it was a narrower, they call it a carrot shape. But basically it is narrower and it flows down more quickly, whereas clay spreads out before it starts to drop down. So if you have sandy soil, you're going to want to put your lines closer together, your emitter spacing a little bit tighter. If it's clay soil, those emitters can be a little further apart, and so can the spacing. So you need to know what is going on in your landscape as you go about designing this. Another thing is that we want to get this even coverage. So one of the things that helps with that is actually offsetting the emitters so that you get this triangle. And when we do that, that's how we get this really nice coverage. Otherwise, everything just lines up and you'll find yourself with pockets where that water isn't reaching the plants as efficiently as it can. Now, even though it's not a part of the rebate, we just wanted to let you know that it's out there in case you go into a store and they say, do you want online or inline? You would understand what that is. So online is you've got solid drip tubing, and what you're doing instead is you are putting in the emitters just where the plants are. So it's another option. And in some cases, if you have a random, this is where you would consider doing it, but you can accomplish the same thing with that inline as well, in that you make sure that those inline drip patterns are going around the plant, and then you go over to the next plant and you do another wrap. So how many emitters per plant? And even though it says online, the thought process is the same for inline. If you've got a 1 gallon, and the thing about the emitters is they come in different flow rates. So you can get an emitter that delivers water in half a gallon per hour, 1 gallon an hour, 2 gallons an hour. Typically, half a gallon is good if you've got a clay soil, 1 and 2 if you've got a sandy soil. Our default is pretty much 1 gallon. You can't really go too wrong with that. But the idea is that you want to have about a gallon per plant. And obviously, the larger the plant is, the more water you want to be applying. So 5 gallons, we're looking at a couple gallons per hour. 15 gallons, we're looking at about 3 gallons per hour. And it is an art and a science. So consider the soil, consider what happens if you have a slope, and also consider what you need when it comes to the root depth. So you may be having questions about now. Ask them. All right, so that was properly designing a landscape. Hold on one sec. Let's talk next about properly installing your system. So when we were looking at that image of an irrigation system, we could see all the laterals, and those laterals are underground. They should be about 12 inches below ground. That's not to say that is where they are. I've seen literally gardens where the PVC pipe is above ground, which is not where it's supposed to be. But the question becomes, well, how do you get the water from pipe that is 12 inches below ground up to the surface where the plants are? So there is something called a point of connection, a riser, and basically you connect to that lateral that is below ground and you bring it up to the surface. And then to that is where you connect your tubing. So in some cases, the image on the right is an example of that. You can run inline tubing below the ground. Um, More frequently, people do it above the ground. It's a little bit easier to see, if something goes wrong. And so you take the riser, you go up to the surface, you add the tubing, and then you lay it out to where your plants need it. Some tips that we have learned from experience, sometimes painful. I'm sure Brent has lots of experience that he can share things that he's learned along the way. The first one is to give yourself some slack. Literally, I was on a landscape job a couple of weeks ago, and one of the plants had to be moved, and there was no slack on the tubing. So they ended up having to cut it and add some additional tubing. If you give yourself just a couple of loops, and it doesn't have to be with every plant, but maybe, every so often, give yourself like a little extra cluster. If something changes, if a plant dies or it grows or it has to be moved or you bring in another plant, then it's really, really easy to adjust the irrigation instead of having to do something a little bit more time consuming. Next up, and some of these seem incredibly intuitive, and yet when you are installing your drip, make sure it is uphill of the plant. Again, I was working with a contractor who shall remain nameless. And when I had asked why they were putting the tubing below, they thought, well, the mulch would get wet, and then that was how the plant got watered. Make life easy for yourself and for your plants. Water flows downhill, flows with gravity. Put those emitters uphill of your plants. Now, trees, you want to give a little extra attention to. So with trees especially, what we want to do is we want the roots to go out, yes, and we want them to go down. So what they recommend is actually concentric circles, and they don't have to be closed circles. It can actually be a spiral that works just fine. But the idea is that that first ring, and this is for a new tree that you're putting in the ground, the first ring needs to be between what we call the container, and the trunk, or rather where the can was. The ring needs to be where the roots are currently. Don't put the irrigation so far out that your plant dies before it has a chance to get there. But once you have that first ring, go ahead and add a second ring so that that is what happens. The roots are watered, and then eventually they will start to spread. And we are also delivering water long enough for those roots to start to go down as well. Now, for some people, if you are taking out your turf, make sure you don't forget about your tree. This tree is accustomed to being watered maybe 3 times a week for, I don't know, 6 or 8 minutes or 10 minutes a cycle. That is how its roots have evolved. So when you take out the turf and you remove that spray irrigation, you need to figure out a way to continue to water it. So it's the same principle. It's a series of concentric rings or spiral, but they are going out much further because the drip line goes out as far as that tree's canopy. So the drip line is where the roots are. So if your tree is 30 feet wide, that's how far out its roots are. So you need to make sure that it is being watered out that far. More details if you are doing this, or even if you're watching a contractor do it. Um, uh, every 3 to 5 feet of drip tubing, if it's not installed underground, needs to be put sort of locked in, if you will. Now, the staples don't go through the tubing. This also seems like it should be intuitive, but you'd be surprised, I hate to say. You want to make sure that it is a full U. Sometimes they have one that's like goes up and then it only goes down partially. That will not hold your drip tubing in place. Again, every 3 to 5 feet, or where there's a curve, or if you've got a tight wrap around a plant, that can help keep it in place as well. The other thing is make sure that it is a round top and not a flat one. That also helps with preventing kinking, which can happen with drip tubing. Now, as far as the placement, again, this image refers to an online where you're putting in an emitter, but the principles are the same with inline, in that the emitters need to be in that root ball area. When you first put in your plant, it is counting on the water that is being applied directly at the root zone, the way it has been raised up to this point. So if you've got your plant here and your inline is out here, your plant will not be able to get the water. So make sure that you are close enough, and you don't want to be right on top of the trunk either, right? We don't want to be watering right up against the trunk. So again, about halfway between those two is ideal. And then making sure that you cover your drip line with mulch, 3 to 4 inches. We are huge proponents of mulch. It serves so many purposes. It keeps the soil cool, keeps the soil moist, covers the drip tubing, and then as it breaks down, it is feeding the soil, which is so important to the health of your landscape. Something else that is a great thing to include is a tattletale. So there is a tattletale at a minimum for each valve. And what'll happen is when you turn a valve on, the line is pressurized. It is ready to irrigate, and that tube will pop up. And it's tattletale because it's telling you that, yes, this line is working. Then when the valve is turned off, it will slowly sink back down, disappears from sight. And if for some reason it doesn't come all the way up or it doesn't come up at all, that is a clue that there's something going on with your irrigation system. And then other things are flush valves. So every so often, you do get a little bit grit or a little bit of sediment that will get into your drip tubing. So you want to be able to flush it out. Different ways that you can do it. What you want to stay away from is an automatic flush valve, because what that does is that flushes automatically every time that valve comes on, which is way more than it needs. We typically say maybe 3 or 4 times a year. So no need to be flushing it that frequently. Now, things to avoid when you're working with drip tubing. The first one is stay away from the spaghetti tubing. It is way too delicate, way too fragile. That little green knob that's supposed to allow you to, water at a particular radius, it just, it comes off. It doesn't work. Too easily damaged. Other things, making sure that the emitters are facing towards the plant and not away from the plant, or being close enough to the plant so that we're watering the roots. And then making sure that your emitter is touching the ground, because it's not like a faucet that goes drip, 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 drip. But what'll happen is the water will come out through the emitters, and then they will actually flow along the pipe until they get to the ground. So make it easy. Wherever you want to be watering, your drip should be touching the ground. Okay. A question we get all the time. People have a spray system and they want to know if they can simply convert their spray to drip. And the key word there is simply. So there are kits out there. They are called drip conversion kits. They can work up to a certain point, but what we wanted you to be aware of this evening is what to be on the lookout for to determine whether or not this is a viable choice for you. The way they work is if you've got spray and it's the right kind of spray body, which is that, where your pop-up is and then it waters, is that you can actually unscrew that and then you can screw the drip conversion portion of it back into that area. And then to that, you can go ahead and attach your drip tubing. Voila, you are done. But here are some things that we would like you to consider. So the first one is, how old is your system and what condition is it? Because if the original system was not all that well designed to begin with, then you are not helping to alleviate a problem. And in fact, if it's an older system or it's been poorly installed, by changing over to drip, you could basically be exposing problems or making them more significant than they were if you had left things alone. So in this case, this is a drip system that is probably as old as the house is. This is actually a project Brent and I worked on together. The next question is, what about those valves? So in the beginning, when we had shown you those anti-siphon valves, we had said you want to make sure that they are low flow valves so that they can appropriately water a low flow system, a system that delivers water in gallons per hour as opposed to gallons per minute. Now, some of the more recent valves that have come out would be able to accommodate that, but these older ones, they don't work. They cannot, they can't sense that small a volume, and so they don't know whether or not they should be on or off. So if your valves are older, look like this, you can't simply do that drip conversion. A big one is, well, can I just at least keep the pipe so I don't have to trench everything? And that comes back to the question of, well, how old is your system to begin with? And even then, you don't know what has happened underground, how things have been jerry-rigged, or poor materials used to begin with. So honestly, as much as we would like to say, yes, you can simply do that drip conversion kit, there are things you need to think about. And then those drip conversion kits only work with certain types of spray bodies where you can, untwist the guts basically of a spray head and put in the guts of a drip system. These are both old spray heads, brass spray heads, and you will not be able to do that with these. I wish I had better news. But it's important to understand what you are getting into when it comes to your irrigation system. It is definitely one of the areas where things can go wrong. If a plant dies, a plant dies. If an irrigation system goes wrong, you've got leaks, you've got floods, people can slip, plants can definitely die. So it really is good to be working with a professional who knows what they're doing, or, if you are handy, to have a good idea of what is happening, and then to be working with good quality materials. So the next question is, well, how in all of this do I know how long to run my irrigation? And I would say more often than not, it really is like throwing darts at a board. People don't know, they guess, hearsay. It's been programmed that way for 15 years. It'll just stay. So this next section is to give you a little bit more guidance on how you make those decisions. This is definitely something that Brent can help you with, and we're actually going to give you some resources that you can use locally. So the first question is, well, when do we actually add water? So we don't want to wait, it's similar to like the gas in your car, right? You don't want to wait until your gas is like at empty before you fill it, right? That can be a little nerve-wracking and it's very stressful on your plants. But we also don't want to be filling it up every day. And it's the same thing with your plants. They don't need to be watered every day so that the soil is fully saturated. So we talked about evapotranspiration, which is the amount of water that leaves the soil goes up into the atmosphere as vapor. And every day, a little bit of water evapotranspires from the soil into the atmosphere. And so every day, that water is being depleted in the soil, drops down. And so anywhere between 30 and 50%, and obviously you're not going to know that, but that is the premise that we work on or work with when it comes to our irrigation scheduling, anywhere between 30 and 50% of the root depth. You need to know what type of soil you have because the water leaves the soil at different rates depending on sandy soil, clay soil, loam soil. So it's a lot of the same questions that you need to be able to answer. What types of plants are you watering? We know lawn needs a lot of water. There are plants that need much less water. There are shrubs, perennials, edibles, all of those have different watering needs. It is not one size fits all. Something else you may need to ask yourself is, do you have a slope? In the guidebook that you're getting, there's actually this diagram that helps you calculate it. But the steeper your slope is, the less your irrigation time is going to be. So you're watering less frequently, but perhaps you're having to water more often, right? Because with that slope, that water is rolling down more quickly. And then, of course, is it sunny or is it shady? So there is a great tool that is available to you, the Valley Water Irrigation Scheduler. This link will be included in the Zoom information that is being sent out to you tomorrow. It is incredibly easy to use. For tonight's presentation, we actually use the address at Valley Water. And they had created a sample watering schedule, 3 zones. One is part shade shrubs, one was full sun ground cover, and the third one was cool season turf. And then you could see with each of those valves, and this would have been created when you go in there and you put in your address, you're going to go ahead and set it up with the parameters of your own landscape. It wants to know the exposure, wants to know the soil type, is there a slope, and then what the irrigation method will be. And so we're going to use this as our data, and I'm going to take you through programming a controller. Who knew? All right, and then with that, and this is so helpful, is you actually get a monthly watering schedule. So for those 3 zones that were input, they provided a monthly schedule, which is great to have. And what's really important to have as far as programming is what is the peak schedule. So we picked the month of July, where it is potentially the hottest, the days are longest, and we are using the most water. So things that we are looking at is how many minutes per cycle, a cycle being your irrigation system turns on. It is possible that you can have more than 1 cycle per day. And that becomes really important, especially when you have spray, where we want to minimize the amount of runoff. And then that third column is, well, how many days are we watering per week? So we're going to be working with zone 1 because that was our drip zone. For the month of July, we are watering 19 minutes per cycle, but it's 3 cycles per day because they don't want the runoff. So we're actually watering almost 60 minutes a week. And we're only doing it in 1 day. So this is a great tool for you to have when you look at your controller and you go, I have no idea how much I'm supposed to be watering. Strongly recommend that you write this information down so that somebody else can see it, so that you don't have to go through this exercise again next year, so that if you put in a new part of the garden with another irrigation zone, you can simply add to it and then not go, oh gosh, what was on zone 4. And then it's a really good idea to actually map it out. This is a great thing to do this weekend. Turn on your irrigation and see what is going on. You want to know how many zones you have, what is being watered for each zone. If you've got spray heads, where are those spray heads? It's great to know because things can go wrong too, like, what's broken, what's watering the car instead of the landscape. What pop-up doesn't actually pop up. So it's a way of actually knowing what is going on in your garden. And put that with your controller. All right, so we're going to start out with manual controllers. We'll talk about smart controllers in just a little bit, but the principles are the same. The information that you need to have before you start are the same. So we're going to start out with a very simple scenario. We have one valve, one zone, and this is a manual controller. There are different models, different manufacturers. They may look different, but they operate in very similar ways, very similar principles. So the zone that we are working with was that first zone. So we had low water using shrubs. We are watering with drip. The soil was clay loam, and it is a part sun, part shade landscape. So as I look at my manual controller, again, this is a sample. Yours may look a little bit different. There are going to be buttons or, cogs or what have you that you're going to need to push or pull or turn. The first one is the run, which is start, go. The next one is the control buttons, and that is what's going to allow you to move through the menu to pick your options. There is a program button. We're going to come back to that one in a little bit. Date and time, obviously it is today and it is right now. Start time, when do you want your irrigation to start? Run time, how long do you want your irrigation to run? And then watering days, what days of the week or how frequently do you want that watering to be happening? The next button is seasonal adjustment. We're also going to talk about that one in a little bit. Run irrigation manually, as the name implies, you're going out to do your irrigation check. You want to be able to run it. And then the on and off button, and a rain sensor. So that obviously if it is raining, your irrigation does not come on. So I'm going to take you through it step by step. The first one is you are going to set the date and time, and you want to make sure that that is accurate. That is not something that you want to ignore or not think about, because everything else is based on that. So when we hit daylight savings, you need to go back and look at your controller. You use that plus and minus and those arrow buttons to help you move through the controller so that you can set the time. And then next thing up will be the start time. So this obviously is per your local regulations. We're not watering in the middle of the day. So depending on what is in your local area, you will set that time. And then what happens is once you set that initial time, all the other zones will follow sequentially. So you don't need to figure out even though we're working with one zone tonight, if you had 3 of them, you just program the first one, and then all the others simply fall in line after that. How long? We've got that information. It's going to be running for 19 minutes 3 times. There is something called cycle and soak. It's a little challenging to demonstrate in this format, and it varies depending on the different controllers. But one possibility is that you run 3 different windows of it, or that you use that cycle and soak. But basically, ultimately, I'm running 3 times 19 minutes or 57 minutes using cycle and soak 3 times. And then you set your watering days. We are only going to be watering 1 time a week, so you would use watering days for that. And then run. Make sure that it goes to run, or auto. Some of the controllers will say auto. And then once you've done that, it is ready to roll. So that was easy, right? One zone, manual controller. Most people have more than one zone. This one actually has 5 zones, 5 different hydrozones, plants with different water needs. We're only going to talk about 2 of them tonight to keep things simple. We're going to talk about our natives, which are low sun shade, and our lawn. So remembering that each of those zones will require its own station and its own schedule. So now is when we start talking about programs. And I think working with programs is perhaps one of the more confusing aspects of working with a manual controller. But the way that made sense to me was looking at each program as though it was a mini timer or a timer within a timer. And what you do is you group zones together based on similar watering needs or irrigation types. So in this case, it's easy because I only have 2 zones, and I'm going to put 1 zone in program A and 1 zone in program B. But if I had another zone that was being watered with drip, say another part of the garden that was full sun, that would be another zone, but I would have it under program A because both of them were being watered with drip. Same thing with program B. If I had ground cover that I was watering with spray, I would put that with program B. So the idea that you sort of cluster families of zones together. Now, as far as programming your controller to accommodate that, this is where that program button comes in. So there's an A, B, some will have a C, some of them will actually have a D, depends on the type of controller. And that gives you the different programs that you can run. So the first thing is you're going to hit that program button, and we are going to start with program A. You pick a start time. So this is all very similar. You enter that in. And then I'm going to show you this next example here because we have 2 zones. So program A is my drip and program B is my spray. But there's 3 cycles in my drip, right? It was 3 cycles of 19 minutes each. And so because it's 3 cycles, that means that they are not running back to back. Oftentimes you need to do like 30 minutes between a cycle. In some cases, it's 60 minutes a cycle. I made it 30 to make it a little bit easier for us tonight. But basically, my program A is going to start at 3 in the morning. So 3 in the morning, that first 19 minutes runs, then it soaks for 30, runs again for 19 minutes, soaks for 30, and then runs that last 19 minutes. So almost 2 hours of irrigation that I need to be setting aside. Then I want to be watering my lawn on spray, and I want to do it before 6 in the morning. So I'm going to start at 5 a.m., which is great. Same thing with spray. You need to do cycle and soak because water runs off, especially with spray, runs off more quickly. So it's going to run for 4 minutes, it's going to soak for 30, and then it will run for the other 4. But what is key to understand here is that program A ended before program B started. If they were to overlap, if program B was set to start at 4 a.m. instead of 5 a.m., the system would have gotten confused and everything would have stopped. So you need to do a little bit of planning as you're setting up your programs, but this is the key thing to understand, is making sure that all your zones run for that particular program and that they are not overlapping with what you are setting for the second one. All right. So then you set your runtime again, whether you have you use the cycle and soak option in your controller, or you set 3 different runtimes. That is a possibility. You're going to use those minus and those arrows in order to do that. And then you go ahead and enter which days of the week it's irrigating. For program A with drip, it was only going to be running 1 time a week. So that was program A. Now I'm going to click program A and I'm going to change it to program B. And it is the exact same process. I've entered in my start time. We figured out that in the beginning. I'm now going to enter in my run time. In this case, it's going to be that 8 minutes with the cycle and soak. And then with the run times, which watering days, 3 times per week. And it may be that that is something that is set, or you go every other day, or, Mondays, Wednesdays, and Saturdays. And then you go to run. So in a nutshell, that was programming your irrigation timer. Hopefully you feel a little bit more comfortable. Again, this will be recorded. You can go back in. You can definitely go online to see how to program your controller. You may still have the directions there, the manual, but it's good to get comfortable with your controller. Now, here's the thing. We programmed it for weather in July, irrigation in July. But the weather doesn't stay the same all year long. We don't want to be watering at the same schedule all year round. The shorter the days get, the less water your plants need. So even though it can be really, really hot in September, October, November, the days are shorter, and that evapotranspiration actually works with solar radiation, not with heat and wind. So less water as we move away from that peak schedule. So potentially, it's peak for June, July, August, maybe. And then in the fall, we're going to start tapering down. In the winter, hopefully we're getting our rains and we turn it off completely. And then come springtime, maybe April, May, if we have, depending on when the rains end, we're going to start bringing it back up again. And the place where you do that is seasonal adjustment. So basically, we programmed it for July, and then you're going to start adjusting down. So you adjust to, 70% and then 50%, and then it comes back on at 50%, and you adjust again. So that idea again that it is a curve, and we're not watering summer watering all year round. And you may be saying, wow, that's just too much. I'd like to get one of those smart controllers. So yes, it can definitely make things easier. Lots of benefits. It automatically shuts off. It automatically does that cycle and soak. It adjusts to the seasons so you don't have to think about it. And they are known to save water over the manual controllers because they keep doing that adjusting long after we have not stopped. So there are potential rebates depending on where you are. When you are looking at a controller, you want to make sure you look for water sense that vets this product, and they are guaranteed to save at least 20% over other controllers that have not been vetted. And I apologize because those rebates are not for Valley Water. I'm sorry I didn't catch that before. Local mini weather stations. So the smart controllers are getting their weather information from a source. That source can be a local source, so literally a weather station that is in your yard. The thing about that satellite, excuse me, not the satellite, the station, is it has to be where the plants are. So it doesn't do you any good if it's like under the roof eaves, or up on a post, over the driveway, because the climate, the microclimate where the plants are, is different than those places, and the plants is what you are thinking about. And then it takes that information, feeds it to the controller, and it adjusts accordingly. The other way that it can get information is via satellites. And then it goes ahead, sends that information to that smart controller, and it is adjusting daily based on the climate as to how much water needs to be applied to your plants. All right, I'm seeing folks have raised their hands. Again, put your questions in the Q&A, and then our panelists can answer. One of the huge benefits with these smart controllers is that they can be programmable from anywhere. on your phone. You could be on vacation, you could be at work, you could be at school, and it lets you see what is happening, last minute changes. Even though they are smart programmable, they still need a little bit of tinkering with. So as far as programming them, easier in some ways, and also very similar. So you're going to put in your address that tells the controller where you are, what kind of weather it's looking for. You set up your zones, so you can give them names: front yard, backyard, natives, fruit trees, what have you. So identify those. And then you input the site conditions, right? So what type of plant do you have? What type of irrigation? What type of soil? So this is all info that you needed to know, that's important for you to know in order to truly manage your irrigation. And then watering parameters. So this may be something that is based on what your water provider or your municipality says you have to do. Or it could be that, if it's drip, you're watering once a week or once every 2 weeks or what have you. And then this is also where you can, say, go ahead and water based on the climate compared to fixed interval, which is where you tell it how frequently to water. So you actually have the option of manually programming a smart controller as well. As far as resources, there's information on the apps themselves. Obviously, there's manuals, and then great YouTube videos in order to understand the nuances of how to work with these. Because they are only as smart as the information that goes in, right? If you have sandy soil, but you've told them it's clay soil, you're going to get a different program. If you didn't think about, am I watering with rotating nozzles or am I watering with spray head? That's different information. Last piece of the puzzle, ask your questions now, and then we'll be going into the formal Q&A in just a few minutes. So basic maintenance is turn your irrigation system on quarterly. Do it this weekend, even if you haven't converted to drip. Just see what's going on with your irrigation system in general. And obvious things you're looking for are leaks. How moist is the soil? Actually, are the emitters near where they should be? And do I need to change that timer? Did this? This is something to do. It's great with the changing of the seasons, right? So spring, summer, winter, and fall. Get a soil probe and go down and see what is actually happening. How moist is the soil below the surface? How far are the roots going down? You might actually see different soil profiles, which is really interesting. So, maybe it was really sandy at the top, but then as you start dropping down, it's different. You might want to get a soil moisture sensor. This you can put into the ground and it will tell you. There's a little gauge there that tells you how much water there is in the soil. And then really important to understand is just because it looks wet on top does not necessarily mean that that is what is going on below ground. So this is a perfect example, especially if you're watering with a hose, or with your spray, or even with your drip. It runs for a few minutes, you look at it, you go, oh, it looks wet. Make sure to dig down, especially if that soil has been parched. It can become kind of hydrophobic. It can actually repel water. So a good thing to do. And then hopefully your plants are becoming established. As they become established, the way we started at the very beginning, the idea is that they would require less water. So in the beginning with new plants, your plants are shallow. The plant is delicate. You're watering more frequently. The soil is more porous. But over time, those roots are going to spread into the native soil, which can hold more water, certainly, than the soil that the plant came in. So we're going to start decreasing that frequency, and potentially, assuming we get our winter rains and we're doing a good job about holding on to that rainwater, maybe you can turn that irrigation system off. So signs of trouble. This is obviously a sign of trouble. The question is, what is the cause? Was it a critter or was it a accidental shovel? This is a bad sign, but don't just assume that it got too dry. They look very similar, the symptoms. It could also be too wet. Now, the great thing about drip is that it is easy to fix. At least the drip tubing is, if you've got, if you punched a hole in it, you can fill it up with a goof plug. If there is a crimp or a kink in the tubing, or for some reason there is a leak, you can go ahead and just snip it. And then there are these repair kits, easy to put back together again. That filter is not there by accident. You do get gunk that will build up in it. That is its job. So a couple of times a year, just, or every quarter. Very easy to do. You just unscrew it, pull out the filter, rinse it out, and put it back in. That flushing quarterly, making sure that when you do turn it on, your flush valve, that it is watering into the landscape and not onto the sidewalk. Making sure that your tubing stays covered with mulch. So lots and lots of times I've walked by a site and, maybe it was initially installed with a lot of mulch, but eventually that mulch will break down. It's supposed to, but it needs to be replenished because if it doesn't, that tubing will start to deteriorate. And then that's how you get those cracks and leaks. And then when in doubt, hire a professional. So again, we said at the beginning, if a plant dies, what is that, $12, $15? If your irrigation system is having issues, you could lose your entire, all of your plants, potentially the water that's being wasted, the impact on your pocketbook when that happens. And we just want to be really, really careful with this resource. So a great source to go is to the EPA WaterSense website. It is Find a Pro or Irrigation Pro. And there you can find people who have gone through a rigorous training in irrigation and bring them out and have them look at your landscape. Plus, as they talked about in the very beginning, which they can go ahead and repeat at the end, Sana or Nick, as far as resources that they have available to make sure you are headed in the right direction. All right. So we've got a few minutes for Q&A. We're going to go ahead and put up a evaluation. That's great to get your feedback as to what worked, maybe what didn't work quite as well. Are there other topics that you would be interested in learning more about? We would very much like to hear that. All right, and if I could get our panelists to come back on, and Brent, it looks like you were staying busy back there. If there's some questions that would be good for other folks to hear, or anything that you would like to make sure came across, that would be great. I'm going to stop sharing here. And he's probably answering questions as we speak.
I was fumbling with my audio video buttons, actually. We had a lot of questions tonight. Some specific, sorry, in a parking lot, and there are loud cars. Susan, I was in the middle of typing, how do you use a moisture sensor? They all come with their own instructions. Some will even, some are on a scale just between wet and dry. Others will actually produce a number, and they'll give you a list with plant names, and they'll say, don't water your lily until you're at number 3. And if it's a higher number than number 3, then there's enough moisture. So some of them work that way. Each model will have instructions. The way I like to think of them is they're, you need to do the same thing multiple times for it to be effective. So if you have a rose bush in the front yard, always measure your moisture kind of in the same place, and you'll start to be able to correlate your measurements with what you're observing. There's not necessarily, you need to take, it's very trial and error, and it's also the kind of body of evidence, not like a silver bullet, one shot, amazing. I hope that answers your question.
Yeah, I think that's actually a great, that whole idea that you're looking for clues, and it's what's the health of the plant, what happens when you go down below the soil, How do things look? Does it feel like a vibrant plant or is it struggling? And then using these different tools to try to narrow down where the potential problems are.
Okay, let's scroll back through a couple of things. So here's what I would say about irrigation. I'm not gonna go back to the question. I'm just gonna monologue for a second. Even the smartest irrigation systems, the multi-$1,000 irrigation systems, cannot replace humans and your observations and your interactions. For example, if you have a spray head that's supposed to be watering your grass and it's turned around watering your sidewalk, no smart controller is able to tell you that. No flow sensor, there is no technology that can tell you that. So nothing can replace your observation and interaction with your sprinkler system. So like Marianne said, yeah, they turn on at 4 o'clock in the morning. They're underground. You don't think of it until something's wrong, typically. And at that point, it's kind of too late. So get out there, turn it on, and look at it. I'm just gonna say it. Turn it on and look at it. I'm also going to tell you that most sprinklers and drip you can handle by yourself if you can still bend over. If you can reach it, you probably have the strength and the know-how to fix it because they're lefty-loosey, righty-tighty, or it's something that you just squeeze together. So don't be intimidated by your system. Go out there and look at it and give it a try. And then when in doubt, hire a professional. Yeah, but I don't want to, I think too many people think it's this mysterious, crazy thing, and there is a lot of science behind it. There are, to do a proper design, to calculate the math, there is definitely a high level required, but if you already have a system, do not be afraid of it.
Yeah. And don't be afraid to ask for help.
That's it.
Yeah. And I think that is the purpose of tonight's class, is to try to explain enough so that whether you're doing it yourself or you're talking to a landscape professional, you don't feel overwhelmed by the terminology or the principles. So even if you do bring in a professional and they start talking about low flow valves and pressure regulators and what have you, you're not going, I have no idea what you're talking about. So it makes you a much more informed consumer. And then, yeah, I mean, YouTube, good grief, you could build a house with YouTube. So the possibility that if you are inclined that way, that you can go in, give things a try, and then go from there. And the other piece is don't skimp on the quality of the materials. That may be a really important thing. This is not a place to cut corners with, getting cheap stuff.
Let's see, we had a couple questions come in right at the end. We told you guys not to save them for the end. But, I suppose you've been listening to Marianne's presentation. You didn't.
There you go.
Yeah. All right, let's see. How do you do different zones in the front versus back of your house? Is there a length of pipe that is ideal? So every different zone is going to require a different valve, and that will give you control over the area. And is there a length of pipe that ideal? That kind of that gets into irrigation design and length of pipe versus size of pipe and flow and pressure. So you may need to consult someone on that kind of installation. I hope that answers your question.
Yeah. And especially with drip, with spray, you've got to be really particular, right, about pressure and how many heads you can put on it. With drip, there's a bit more permission, a bit more flexibility.
Yeah, a little more forgiveness for sure.
A little bit more. I wanted to, because we have to wrap up about 7:25. Nick or Sana, was there anything that you wanted to say or reiterate? And I did talk about the controllers, and if you don't mind clarifying whether or not you offer a rebate on the controller as well, so that we make sure that we give folks the proper answer on that.
Yes, apologize. I have to keep my camera off. I'm surrounded by family right now, but We do offer a rebate of up to $300 for smart controllers. So this is switching out from an old-fashioned controller to one of the smart controllers that we talked about. I included a bunch of links. We got a few questions about professionals. As a government agency, we can't recommend anybody, but we do have a list of professionals that have worked with participants in our rebate program and in our gray water rebate program. So I put that list in the chat. And also there was questions about soil moisture meters. We offer those for free for Santa Clara County residents. So that link is also in the chat. And I think that's it. That's all I have.
Great, super. Any last burning things you want to share, Brent, before we call it a night? Nope. All right. Well, thank you everyone for having joined us tonight or for watching it in the future. Hopefully there was some good information, some good guidance to point you in the right direction. And thank you, Valley Water, for hosting tonight's class.